In today's video, I'm going to show you how I made this super bright LED flashlight using an Aldwich tin and some cheap electrical components. Let's get right into the video. To build this, I used an 18650 battery with a battery holder, 3 1-watt LEDs, a heatsink, a switch, an adjustable step-up transformer, and a high-power LED driver. If you've never worked with high-power LEDs, here's a simple explanation of how it works. These LEDs require specific voltage and current, which is why a driver is used. For this driver, once I input 12 volts, it puts out 300 milliamps, and the voltage is determined by the amount of LEDs that are hooked up. This one is capable of powering 1, 2, or 3 LEDs in series. This is the circuit diagram I made for this project. The battery only puts out around 3.5 to 4 volts, so this module is used to step it up to 12 volts, which is what the driver requires. Then the driver is connected to the 3 LEDs that are in series, and of course a switch will be used to turn it on and off. To begin, I started by soldering the 3 LEDs in series, then soldered a wire to each terminal. Once the LEDs are connected to the driver, the LEDs will produce a lot of heat, and if not dealt with properly, the LEDs could damage after a couple of uses, so that's why I'm using a heatsink. Here's a look at how I got mine. Inside of these laptops have very small heat sinks, which is used to dissipate the heat from the CPU. When you open up an old laptop, you can see there's a fan here, and then the CPU is located underneath this heatsink. This produces a lot of heat, which then goes to here, and then dissipates through these fins in the heatsink. Of course, I don't want to use the whole thing because it's too big, so using a hacksaw, I cut off the part that usually connects to the CPU. This leaves me with a mini heatsink with some sharp edges, so using a grinding stone, I smoothed out those rough edges and made it ready for the LEDs. For this next part, I used some thermal paste. This compound is used to transfer the heat between the metal on the LEDs and the heatsink. First, I put some thermal paste on each LED, then placed them onto the heatsink. Then I used some 2-part epoxy around the sides to hold all the LEDs in place. To mount this onto my case, I used 2 popsicle sticks, which gave this lid clearance to be able to open and close easily. I just glued the heatsink to the Aldwich tin, and once that's fully dried, I'm going to continue with installing the rest of these components inside of the box so that we can light these LEDs up. 8 hours later, and the epoxy was as hard as steel, which means it's time to put the rest of the components in place. First, I marked and cut a hole on the top of my case for the switch. Then I pushed it through the hole and used hot glue to hold it in place. Using my rotary tool again, I drilled 2 holes on the side of the case for the wires coming from the LEDs. Once they were in place, I used hot glue again to hold everything together. Now the rest of the components are ready to be put inside the case. I started with the battery holder as it was the biggest part. The battery holder was a bit too tight for the batteries, and I know I will have problems with getting the battery stuck. So using my X-Acto knife, I cut off the pieces of plastic that usually hold the battery in tight. Then I used a generous amount of hot glue to hold it to the case. Before I soldered the driver and the batteries to the boost converter, the output voltage needed to be set. This was done using my multimeter and a screwdriver. The output voltage changes when the potentiometers turn clockwise and anti-clockwise. I needed 12 volts to come from the output terminals, so when my multimeter displayed 12 volts, I stopped turning the potentiometer and continued with soldering everything together. Right now everything is connected up according to the diagram I showed earlier. The only thing that's left to be done is to hook up the switch, and these 2 wires are what control when the LEDs go on and off. I tap them together, the LEDs go on. Once everything was soldered together, I used hot glue to hold everything to the case and was careful not to let any of the wires touch the case because it's metal and I don't want to blow anything up. I was curious to see what would happen if I put the battery in backwards, and within moments my booster board was dead, which meant I had to take him to the graveyard and lie among his fallen mates. Once again, I put everything together and the build was done. These 18650 batteries are rechargeable, and I did build the charger in the previous video. You can click here or the link in the description to see how I made my charger. These LEDs are super bright, and the camera does no justice to show how bright they actually are. This makes a great camping flashlight, and I'm starting to wonder what would happen if I use 6 LEDs instead of 3 next time. But I think this video is getting long enough, so I'll save that for another video. As always, leave a comment down below if you have any suggested projects, and be sure to subscribe to catch my future videos.